There we go. Okay, so as I was saying, this is the website. Okay, and if you go in here, you'll see a little bit about the syllabus and about myself, and the way to contact me. As I was saying earlier, the best way to get a hold of me is by phone, right? Okay, there it is, 978-761-5742, or text me. Again, if I'm not on a meeting, or if I'm not teaching, I usually respond right away. Or if it's noontime or after hours, maybe between 5 and 7, please call me. I mean, you can call me anytime, right? But if you call me after hours between 5 and 7, you're doing me a favor, right? You're calling me during my commute, and I tend to fall asleep. And if you call me, you can keep me awake during the commute, right? It's a perfect time to call me, and so that to save my life. You'll save my life if you call me between 5 and 7. Otherwise, use Piazza. Send a message, ask a question, so that everybody can see the question and everybody try to answer. Make an effort to answer somebody else's question. Right? I keep track of that. Piazza keeps track of those kind of statistics. Right? Who asked more questions? Who answered more questions? Right? And that goes towards your participation. Right? All the statistics will show you, how many, who asked most questions, who answered more questions. If somebody answered correctly or it was useful, just give them a good answer or a good question, right? That also works towards their participation. Also, I'm on Google Hangout. If you use my personal email, jnunzi@gmail, we can jump on a Hangout, right? If you need one-on-one help, we can jump on a Google Hangout, and I can help you right away. Also, all your code is going to be available on GitHub, right? That's the main way that you're going to be submitting your assignments, right? Each week, you're going to be submitting an assignment. You're going to tag it. You're going to tag it as assignment 1, 2, 3, or whatever, and that will be your submission. That will be your assignment submission. The TAs and myself, you will invite us as collaborators to your GitHub repository. We'll be able to clone down your repository and grade you, right? Because you're going to tag your assignments, you're free to keep going and work on the next assignment. Right? There's no need for us to grade it. That you're going to break something. It doesn't matter. It's tagged. We can always clone the assignment at any time, any moment in Git history. Okay. But it's very important that you tag the assignments. Also, I'm on Skype at jose.ananziata. Email, you can also email. If you must email me, that's the worst way of getting a hold of me, email. I get a lot of emails, and what I do, I filter them so that everything that comes from neu.edu goes into one inbox, so that I give those priority. So if you're going to email me from your neu.edu. Okay, don't use your personal email because it'll take longer. Right? Use your Husky account, Husky email, so that I filter it and I give it priority. Okay. What else? Office hours typically. I think what I'm going to do is that I'll be here all day Tuesday and all day Thursday. Okay. Well, at least in the afternoons. After noon time all the way up to 9:30 today. Right. So I'll be available on Tuesdays and Thursdays. If you want to come see me, I'm at 460A. 460A West Village H. Okay. Typically, what I'll do is that I'll send out an invitation on Doodle.com. Anybody use Doodle.com before? It's a scheduling application that allows you to provide certain slots of time so that people can schedule and come see you at that particular time. Right? I'll schedule 4 or 5 slots per day. Right, so that you can schedule and come see me at those times. If you schedule a slot with me, but can't make it, please uncheck yourself, right? Unschedule yourself, and and post something on Piazza saying, hey, I can't make it. If anybody wants to take up that slot, please take that slot. Please don't be rude and slot and just not come, right? You're taking somebody else's time that they could have used that slot. Okay. All right. What else? There are no exams. No exams, no quizzes. The assignments, there's going to be 6 assignments, right? The first assignment will be to set up a development environment, right? And that's going to be due at the end of this week, on Sunday. Basically, you're gonna have to, we're going to make sure that you have a development environment, right? That you can code, you can have something running by the end of the week, and that whatever you're running on your machine, you should also be able to run it remotely on a hosted server. Okay, we're going to be using OpenShift as our hosted environment. It's free, and up to a point, right? I think you have 500 megabytes of storage and databases, and it provides everything we need. It provides a database, MongoDB, provides a server, Node.js, and a third, whatever you want. But typically, they call them gears, 3 gears. Typically, it's useful. Other tools, they have other tools there for development purposes, such as a database client or things like that. So that's going to be the first assignment. The next assignments are going to be, building a mean stack application. All right, we'll start at the client side, right, and work our way towards the back end. Right, we'll start from the front end, HTML, CSS. That's going to be the first assignment. Then we're going to add JavaScript, jQuery, Angular. Second assignment. We'll add the server. The third assignment. We'll add the database. Right. We'll add security, right, and web services. So we're going to work our way back from front to the back, right? The assignments are worth 42%. 6 assignments. I want something divisible by 6. Although I reserve the right to change these percentages a little bit, tweak them a little bit. So 6%, 42% for the 6 assignments. Usually, I'm very lenient with due dates, but on a very short semester, I don't think I can give myself that privilege. Right? It's going to go really, really quick. Okay, you're going to blink, and the semester's going to be gone. Right? And says, oh my goodness, what happened? Right? So to make sure that we are on time, and I don't think I'm gonna have a chance to change those due dates much. Right? Also because it becomes a nightmare for the TAs on back and forth. Are you done? Is it okay to grade now? Blah blah blah. It's just we can't do that on such a short semester. So I'm gonna stick to the due dates, right? And instead of you asking me, can I have a couple more hours, right, to finish this, don't even ask me. Right? So what I'll just do is that go ahead, take those 2 hours. It's just that you lose 1 percentage point for every hour that you're late. Okay, that'll be much easier for us to, to have a fair policy for everybody. Okay, so that if you need a couple more hours, that's fine. We'll just grade you over 98. Right? It'll be easy to just plug it into our spreadsheet, and everything will be calculated automatically. All right. If you need a full day, or 15 hours, you'll be graded over 85. Okay. Right. Project is 50%. So project is very, very important. Now the course is the intention of the course is to have you work on 2 projects. Right? One of them is the assignment, is is what you're building for the assignment. The assignment is one big project. Again, you're going to be building an entire mean stack application from beginning to end for the assignment. And the intention would be that as you work on the assignment, it says, ooh, this is how you build HTML files and CSS and JavaScript and whatnot. You replicate that for your project. Okay, that's the intention. Although that hasn't ever worked like that. You know, most of you either wait to the mid of semester to actually start working on something. But the intention is this, right? That you learn by being held. We're hand holding you, as you telling you how to build something, right? And then what you learn from that, you then apply to build whatever you want on your own. Make sense? Right, so that's the intention. I understand that you still have to think of what is that you're going to build, and that's going to take a little bit, but don't let it fall too behind too much. Okay. The agenda. Here's the agenda. 7 weeks. It's the very first time I ever teach this in the summer semester. Okay, I always taught this for 3 years, always in spring and fall. It's the first time I teach it in the summer, so it's going to be challenging. I think I've only removed one topic, right? So it's mostly no. Like the topic is there, but there's no assignment for that topic. Last topic. That's the only change I've done. But everything's here. Let's see, the first week, which is starting today, we're going to be setting up a development environment. And this means we're going to set up our local server. We're going to have an environment locally in our machines with our local server running on our machine, a database running on our machine. We're going to have an IDE, and we're going to have a repository, a local repository. We're going to do all our work locally, right? And periodically, hopefully daily, you will be publishing this to a remote server that has a remote database, right? And everything you have running locally in your machine should be available. Okay, not the database, although we can transfer data as well. We could do that too. But your local database will have nothing to do with the remote database, right? So the data, you'll need to recreate it somehow, or transfer it, or import it remotely. But yeah, so we're gonna have that running this week. Hopefully, also we'll get started talking about the mean stack, HTML5, responsive design, mobile first. So yeah, so that's one of the bigger topics and focus of this class, is that we're going to be heavily focused on mobile first. Mobile first. I'll keep saying this over and over throughout the semester. Right. One of the first things that I'll do when I grade your project is to see if you are mobile friendly. Okay. Right. So I'll put it in I'll visit your website with a phone and see that it should work perfectly. I should be able to use it just as well. Okay. And we've all seen the importance of this philosophy. The growth, most of the growth in web traffic is on mobile phones and tablets, and so it's incumbent on us to design and implement to the larger demographics, right? Even Google, for instance, they on their search engine, they favor mobile first applications, right? Mobile first websites, right? So that's where the demographics is going, and that's where we should be. Right? We should be catering to the larger population, right? So yeah, so definitely we're gonna be looking at that this week. We're gonna be using a mean stack. So again, no other stacks, please. Right? Otherwise, it just makes it too crazy to grade, and it becomes becoming a little more subjective. if we standardize the rubrics for this particular stack, it makes it easier to give you a grade and feedback. Mean stack. Well, I don't know that. So mean, real quick. The mean stack is it's an acronym that is based on the several of the many technologies that are part of that framework. So it's mean. It doesn't mean that you're mean or anything. It's not an attitude. It stands for Mongo, DB, Express, Angular, and Node.js. Okay, these are the four of the technologies that prominent technologies that we will use, right, to implement this type of applications. Some would argue that it's not a stack at all, that it's not a framework at all. And it's true. Yes, it is true. These are four technologies that happen to work very well together, right? But they're not in any way associated or related to each other, right? They don't work in tandem. They just happen to work very well together. Okay. MongoDB being a database, a NoSQL database, a JSON database, an object-oriented database that allows you to store objects, right? In particular, JSON or JavaScript objects, right? Natively, so you can query, you can store, retrieve, manipulate JSON data in a database, right? In MongoDB. Angular is the front end, right? See, it's a JavaScript library that allows you to very easily manipulate the client, the browser, right? To dynamically render pages based on JSON data. Right? Allows you to map JSON objects, right? The arrays and relationships, map them to a DOM representation, right? It provides a very high-level way of thinking about web applications, right? It hides from us the fact that underneath we're doing DOM manipulation, right? Nowhere will we see in Angular that we are deliberately manipulating DOM objects, right? Or changing attributes or classes or things like that. Even though you can, typically we stay at a very high level, right? And let the low-level handling of the DOM to the low-level intricacies of AngularJS. Right. We will take a look at jQuery as well as a helper to AngularJS. jQuery is another very popular library which we'll cover that is used more for direct DOM manipulation, right? Than it allows us to think of the DOM of the browser in a standard way, so we don't have to think about different versions of JavaScript, different versions of browsers. Right? jQuery allows you, to create an abstraction of these browsers, right? So that you can code to this high-level browser, right? This virtual browser, so that you don't have to, be bothered with the intricacies of each version or each vendor. Okay. So jQuery is from the point of view of Angular, jQuery is a very low-level library, right? It's a DOM manipulation library. Angular is way up here, right? Where it thinks in a different way. It thinks about it in a very architectural philosophy of breaking up applications into design patterns, right? Controllers and watchers, right? And listeners and views and models. Okay. So we'll talk more about that AngularJS a little later. Node.js, the only thing Node.js is very simple. It's just the ability to be able to execute JavaScript, but on a desktop, right? On the server side. Typically, when you think about JavaScript, the first thing you think is that, it's the browser programming language, right? It's a language we use to dynamically, interact with browsers, right? Well, Node.js allows us to use JavaScript, but on the server side, right? There's tons of other languages that we can run on the desktop, right? Java and C# and PHP and all these other languages. And Node.js is not it's not any more interesting. JavaScript is not any more interesting than any other language, all by itself. What makes a particular framework or language interesting is all the support, right, and libraries and participation by the community on all sorts of libraries and plugins and modules that allow you to very quickly build interesting and powerful applications. Node.js has a very active community, open source community that creates really, really powerful modules for the server side. Okay, so yeah, Node.js in particular, one of the modules that is one of the more popular modules is this one, Express. Express is one of those modules, right, that allows us to, in 3 lines of code, implement a server, right, to have an HTTP server in just 3 lines of code, right? You bring it down to 2 lines of code, right? And it says, I want an HTTP server, require Express, listen to this port, done. You have a server running, right? And then with just a couple more lines of code, you have a file server that's serving HTML and CSS and any other static content. So 3-4 lines of code, you have a working HTTP server, right? And with just a couple more lines of code, you have a web service, right? That is sending back data, right? JSON data from the server, right? And a couple more lines, and you have database connectivity. It's very, very powerful, very, very easy to use, and that's what's going to be one of my goals in this class is to demystify as much as possible web development, right? To hopefully you'll say, you'll come to say, it says, oh my goodness, is it that easy? Is it really that easy, right? So that's going to be my hope. Right. So the first assignment which is due this Sunday is development environment. Okay, and we'll go over the assignment in a minute. Yeah, so each assignment will be due at the end of that week, right? And we'll start grading that Monday. This should be one of the easiest assignments, okay? There's a lot of gotchas here and there on setting up the environment just fine. So I want to give you time to make sure that you are ready to that you have a working environment by the time you start implementing in earnest. Right, so we'll get started with mean and HTML5 even today. Next week we'll get started with we'll finish up Bootstrap and grid systems. Right? There's been many libraries, CSS libraries that have come out that make it very easy to implement mobile applications, right? To have applications that are responsive, right? That easily adapt to the size of the screen, whether it's a vertical phone or landscape or tablet or desktop, right? So we'll take a look at one of the more popular library, which is Bootstrap. It's a CSS library that allows us to very, very quickly implement, professionally looking applications. Again, not websites, applications, right? And Bootstrap is really nice at that. They really are catering to the needs of the developer, right? So they have tons of different little widgets and layout, for people that are building applications, not websites, but applications, right? Really, the web has finally become a legitimate development framework, right? It's a framework where you can actually build applications, right? Just like you would use maybe .NET or might use for building desktop applications, right? That would use Visual Studio to implement. So also next week we'll start with JavaScript, jQuery, JSON. So JavaScript, as I was mentioning earlier, is the typically you would think JavaScript as the language of the browser, but no longer is only for the browser. It's also for the server, and it's also for the database. It's JavaScript everywhere. JavaScript is taking over the world. One of the things that this will simplify is that you have to just master one particular language, right? And that same language, you can use it for the client-side development, for the server-side development, and also for the database development. Okay. As we go on, we'll introduce also JSON as the standard way of sharing data back and forth between clients, right, servers, database, and even third-party APIs, right, that are making their data available through JSON, RESTful APIs. And what this will do is it will simplify, right, the data transfer, the data storage, the data manipulation, right. In other frameworks such as J2EE or .NET, right, we have other challenges such as typically referred to as the impedance problem, right, where you have data that is transferred from one layer to the next, right. Usually we have a multi-tiered application, right, where you have data represented on the client one way, then you need to represent it again in a different way in objects in C#, and then in another different way you need to represent it in a relational database, right? And there's always a translation challenge, right? How do you translate from these three different ways of representing the same data, right? For instance, in C# or Java, you have inheritance, right? You have objects that are heavily inheritance. You have overloading, overriding. You have all these really cool object-oriented concepts which are not necessarily transferable to a relational database, right? Which is just tables and flat tables, right? And you have to what do you do with the foreign keys and primary keys, right? To map those to classes and instances. So all those are challenges that are mostly solved, right? We have ORMs that do this, right? We have ORMs that object relational mappers, right? That bridge these two worlds, right? But over here, we're not going to have that issue. There is no transfer. There's no transformation unless you want to, right? If you want to transform it in a particular way, because you want to convert it from a very hierarchical representation to a very much flatter representation, yes, and massage the data in some way for the client. Well, it's your choice, but it's not being imposed on you by the framework. Yes. Same thing with the client and the server. Usually there is also a conversion between the data representation in JSON. I'm talking about JSON in Java and C#, right? From the object model in JavaScript to an object model in Java or C#. Again, there's another translation layer between those two worlds. Over here, there won't be a translation layer, right? It was JSON in the client, it'll be JSON on the server. Okay, no translation. Okay, so a lot of these issues are going to be simplified by standard representation, right? Standardizing on the language and across the multiple tiers. Okay, we will introduce jQuery again. jQuery, the library that is going to provide a layer of abstraction for the browser. It used to be that before jQuery that we were coding for browser, a really modern browser, and because we're developers and we're on top of things and we want to have the latest of everything, and it turns out that they're visiting our websites with IE, IE6. It says, and all our really cool features are not working. What's going on, right? And so it says, oh my goodness, yes, I have to code for IE. I need to detect that it's IE, this version, that other version, this other vendor, this other versions of JavaScript, right? And we used to have tons and tons of code with lots of if statements, right? If it's this version, if it's that vendor, if it's this and that, if this object is available, if that object is not available, it's just a mess, right? So somebody said, well, can't we modularize this, right? Can we centralize this instead of having this all over the code? Can we create a library that handles all this low-level stuff, right? Detection and I just want to have one function that if I call that, I don't have to deal with, I want to have it behave the same way in all browsers, right? So that's what jQuery. That's where jQuery comes in. If you want to add HTML or remove a node from the DOM or add something or manipulate things or makes things draggable, right? It's one function call, right, in jQuery, right? And jQuery takes care of who the vendor is, the version of the JavaScript. All that is abstracted from you. You don't need to deal with those things. Okay. So yeah, jQuery. We're also going to be using some of jQuery's really cool behaviors. Not only DOM manipulation, but user UI libraries that allow you to make things draggable and resizable and animation and do really, really cool behaviors. We'll add a couple of those to our application, right? Ajax. So Ajax is going to what is going to allow us to implement single-page applications. Single-page applications heavily rely on Ajax. Okay, so Ajax is a mechanism that allows us to asynchronously, programmatically go and talk to the server. I mean, browsers do this already, right? When you type something at the URL of the browser, a request goes out to a server, right? And that server responds with some static data, right? Some static ASCII, right? Either HTML or CSS or JavaScript, right? Or some image, right? These are all static content that you can access by typing at the URL. Or if you click on a hyperlink, again, another request is made out to the server, and the server then responds with a file with some resource that gets rendered. Yes, but we don't want to do that when manually as users click here and there. We want to be able to do that programmatically. We want to be able to on demand go out to the server and ask for data, right, or ask for a resource on the server. To do that, we have the Ajax API. The Ajax API allows us to programmatically on demand, whenever we want, right, go out and make a connection to the server, right, and ask for resources. Okay, and that's one of the things. When I first looked at how MapQuest, Google Maps says, oh my God, I flicked the map and the map started flying, right? It says, how do they do this? It says, all these images. I mean, it must be huge. It says, obviously, when you start looking at the browser, all the requests behind the scenes, you see all these Ajax calls, right? Querying for more images to fill in the empty spaces, right? The page is not refreshing, right? Instead, it's generating all these requests programmatically, asking for more images to fill in the images in the empty spaces, right? So single-page applications rely heavily on Ajax, right? Because single-page applications, did I say that's what we're building? We're building single-page applications, yes? I said that, right? We're building single-page applications where typically what happens is that you load the first page, right? The wrapper container page, the index page, yes? And then you never navigate away from that page. You stay only in that one page, right? And then what you do after that is that as the user interacts with the application or the website, you use Ajax to go and fetch more content on demand, right? If you click that you want to navigate to your profile or to the posts or to the images or whatever, right? It makes additional requests to fill in the page or to replace the DOM, or the current content with new content. Right? It throws away the old content and then replaces it with new content, right? Giving us the same functionality of navigation, right? Of going from one page to the next. For us, it's the same functionality. It's going to be smoother. There's not going to be any harsh refreshes of the page, right? It's going to be a much better experience, right? And we're going to be going fetching data on demand to fill in the content of that page. Plus, not only are we going to fetch content, we're also going to be using Ajax to fetch for data, raw JSON data, right? Data that is not meant to be consumed by users, right? It's going to be raw, arrays and objects, not binary, but nevertheless objects, right? That are going to be then used in JavaScript to manipulate the DOM to render dynamically that content, right? As we interact, if we want to remove somebody because we don't like them anymore, or we say we give them thumbs up, right? All these are going to be data exchanges from the client to the server to say, hey, this person liked this review, right? Or this person commented on that review, okay? Or this person is now following that other person, right? All these are going to be JSON exchanges between the client, right? The JavaScript on the client with JavaScript on the server, right? It's going to be listening for these incoming requests back and forth, storing in the database, right? Synchronizing the data that is being rendered on the view, synchronizing with data being stored in the database, right? So one of them is going to be temporary, going to be transient, what you see on the website, but it's going to be long-term storage, right, in the database, right? So yeah, lots of AJAX. Then on the third week, after having done some low-level JavaScript, right, we're going to introduce Angular. So Angular is going to be the library that we're going to be using. It's the A in the mean stack. Maybe we'll get to do Angular earlier than that, hopefully. It's the A in the mean stack, right? Angular is going to provide a brand new way of thinking about web application development. Okay? Angular is going to force us to think in web development using this architectural design pattern called MVC, Model View Controller. Right? So Model View Controller has been around for quite a while, has been used on server-side web development for almost 2 decades, right? And has served very well. Right? Has been very successful organizational architecture, right? That allows to break up a complex application into at least three pieces, right? That have a very well-defined task, right? And also somewhat defines the skills that you might need to succeed at any one particular, right? So for instance, the view is responsible for, like the name suggests, to interact, the immediate interaction with the user, right? So it's where we lay out the page, we display all the form information, the images, the marketing, right? And it's pretty, and it's colorful, and it's very pleasing to the user, right? And that has its own set of skills, right? There's people that are very good at that, right? Then we have a little bit towards more in the back, right? We have all the logic that goes behind that, right? Somehow we need to fill the data that the view needs, right? We need to go fetch the list of movies or the list of users, or we need to check to see if the user's logged in, and if they're not logged in, we need to send them to the login page, or if they are logged in, we're going to send them to the profile. All this logic on how the behavior, right? What's the behavior and how it reacts as a user interacts with the application is the responsibility of the controller, right? The controller or set of controllers are responsible for interpreting the user actions, right? What the user is doing, and then reacting, right? And either delegating the task to other controllers or other services, right? And then responding to the user with data that was requested, or providing data that represents a new state of the application, right? You've removed something, well, you should provide a new piece of data that does not include what they just removed, right? The controller is responsible for receiving all these events, right, as the user interacts, and transforming them into some manipulation of the model, right, of the data, and then providing a new model or data to the view, so the view can then render this new state. Okay, so that's the responsibility of the controller. Now, classically, or in legacy systems, well, I call them legacy, they're still very relevant. these controllers have lived on the server side, right? Also, the rendering of pages also has, mostly lived on the server side, either rendered using ASPs or JSPs or PHP or Python, right? When we dynamically render these pages on the server. Angular has taken these ideas of the model, of the view, of the control, right, and applied these ideas that have been very successful on server side, and apply these ideas now on client. And because we have been building more and more complex web applications, right, more centered on the client, right, closer to the user. And since these have become more and more complex, we have to think about how do we structure things. How do we divide and conquer? These larger applications are heavy, on the browser, running on the browser. We need to break it up and think about it in smaller pieces, right? So Angular, that's what it does. It takes these three ideas and applies them on the client. The third one was the model. The model is the responsibility of the model is to represent the data and the relationships between that data, right, in some format. In our case, it will be JSON, right? We'll be representing users and movies and reviews and people are following and comments and all sorts of things, right? We're representing this in some UML class diagram, right, where we're gonna formalize the relationship between all these different entities, right? And the model is responsible of representing all these relationships, all this data, all these properties, all these data types, right? And also enforcing certain rules, right? If you remove something, you need to remove those, right? If you add something, you need to update something else, right? Somewhat taking care of referential integrity, right? And that the relationships are maintained, right? Are fulfilled. This was true in Solus and in legacy applications, right, where we use ASPs and PHP and JSP, but now it's even more on the client side. So Angular has been around just for a couple of years, but they have been implemented using this design pattern. And Angular is not the only one. There's quite a few others are using the same design pattern, right? Model view controller, MVC libraries. Okay. So we're going to be using Angular JS, routing the mechanism that is going to allow Angular, right, to implement the navigation between pages, right? The navigation is not going to be implemented the way we usually implement it, by hyperlinks, right? You have a hyperlink, you click on the hyperlink, you navigate to another page, right? The way we used to do that is no longer going to be true, right? Because it used to be that if you click on a hyperlink, an entire new page got loaded, right? If you click another hyperlink, yet another page get loaded, right? All that is gone. It's not going to happen anymore, right? But we do want the functionality. We do want the functionality of, if I click on something, I want to see something else. Right? That is the general gist of it, right? Well, Angular is going to allow us to do that functionality through routing. Modules is going to allow us to break up into smaller pieces that work together, so that we can deal with complexity. Directives are a mechanism that Angular provides that allows you to define your HTML. If you don't like HTML, you can define your own HTML. Okay, you can define your own markup language. Directives allow you to create brand new elements, brand new attributes, brand new classes, right? Or you can redefine the existing ones. You don't like how input works or tables work, you can build your own table. Okay, and it'll behave the way you want it to behave. Right? You can redefine the entire HTML. Okay, so Angular allows us to own our own HTML, either redefine existing, our own. You can create your own HTML elements. Route parameters, being able to read URL, right, and based on that URL, show a relevant content. That's something that's a topic that's going to go with us the entire semester. Is that the state of the application, right? Whatever you see on the page should be uniquely represented, right, or captured or encoded somehow, right, in the URL. Right? The URL should always represent some unique state of your application. Right? I should be able to take that same URL and send it over to someone. Right? And they click on that URL, they should be able to see exactly what I see. Right? Now, in classical applications, that's obvious. Right? Because if I have a URL, it can only be that content. In static applications, it's obvious. In dynamic applications, it's a little more complex, right? Because in dynamic applications, the HTML doesn't contain any data, right? It contains only the layout, templates, but no data. So somehow we need to map, right, whatever parameters are on the URL. We need to map that to, several database access and queries, right, and updates, right, and retrieve and reconstitute the page based on that one URL. You see that? Right? Right? Somebody sends me a URL from Amazon, right? And I click on that URL, presumably I will see whatever they saw, right? Now, it's not true that Amazon has a unique actual static page for every product, right? All these pages are highly dynamic, right? Grabbing and data from all sorts of different places and services and aggregating all this data to build a page, yes? But whatever you see should be uniquely identified in the URL. So the URL should always represent your state, okay? Also because it's important, because single-page application introduces the challenge of the back button, right? The back button challenge, right? Single-page applications, as you're interacting with them and you go back in history, the expected behavior is that I should go back to whatever I was looking at earlier. I mean, that's obvious, right? It's an expected behavior, right? In single-page applications, it's not necessarily true, right? Because they're dynamic, they're completely dynamic. You don't have a page there with the actual data, right? So Angular is going to allow us to maintain all these states, right? And reconstitute all these pages based on the URL state. And yeah, so we're going to use MVC and controllers, which I talked about already. So on the fourth week, we're going to be using a little more Node.js. We're going to be using Node.js right away, okay? But we're going to be using mostly to serve pages, right? To serve static content, to serve CSS and HTML and JavaScript, right? So it's going to be a trivial use of Node.js, right? But starting on the fourth week, we're going to revisit Node.js and we're going to start looking at some more advanced features. Okay. So for instance, up until week 3, all the content, all the data is going to live on the client, right? On JavaScript and none of the data is going to be stored anywhere, right? If you refresh the page, any updates that you had done are gone, right? Because we don't have anywhere to put it, right? The browser has nowhere to store it. So we're going to need to ask for the help for the Node.js server to be able to interact with server-side services, right? To store our data, we're going to have to post the data. We're going to retrieve data, delete data. I'm going to send these to the server so that the server can then store it either in a database or store it on the file system, or maybe make a network connection to Flickr or whatever, right? To post data to our third-party APIs, right? So we're going to revisit Node.js and Express, so that we're going to be able to use define web services. The idea of web services have been around for a while, and the idea when they just came out was that hey, you have all these disparate systems, right? If we could just wrap them in some layer, right, in some abstraction layer, we could have them talk to one another somehow, right? If we have them talk the same language, maybe some language that has lots and lots of stupid, pointy brackets. Maybe if we could all standardize on XML, maybe we could have understand each other, right? Regardless of whether you talk Java and I talk PHP and you talk C# or you talk whatever, right? If we all talk XML, we can all talk to one another, right? So this was the promise of web services way back at the beginning of the century, and it worked very well. It turned out to be much harder than we thought, but nevertheless, the technology stayed with us, the idea stayed with us, and today it's a very common technique that we use to expose server-side resources, expose them to anyone, right, who wants to access them. So that's what we're going to do. We're going to expose server-side resources to our Angular applications, right? Our Angular applications are going to be running on the client, on the browser, and because the browser is very restrictive, right? The browser doesn't allow Angular to access the local file system, right? It doesn't. It allows very limited network connectivity, right? It has a running in this security black box, right? It doesn't allow you. It needs to go back to the parent server where it came from and says, "Hey, I need data. I don't have anything to show." And it's going to have to come back to the server and ask for data, right? And that's what we're going to do. We're going to use web services to expose server-side resources such as query the database or file system or network connections, right? Right. So that the client can ask for data and post data or put data or delete data. Okay. Right. So up to this point, we're going to be a server-side development. It's going to be due that Sunday. Notice that each week there will be an assignment due that Sunday. It's very, very aggressive. Okay, but that's the nature of of half the time. Right? Typically, these would take 2 weeks to complete. Right. But we're targeting to do this in half the time. All right, so on the 5th week, we're going to be talking about MongoDB. Right, so we introduce the database. Right, so this is where we're going to first see a way to store data permanently. Right, up to this point, the data only lived on the client, on the browser. Then now finally lives on the server. Right, and finally we're going to have a place to put it permanently in the database. Right, and we're going to be using MongoDB, which is the M in the mean stack, right? And it's a NoSQL database, meaning, as the name implies, we're not going to be using SQL. It's not a relational database, right? Like you might be more familiar with. It's I would say, if we had to reinvent databases today, what would it look like, right? Each new technology that we design is typically based on the problems of the times that we were trying to solve, right? The problems that we're trying to solve at that particular moment in time. Today, we're trying to solve the fact that we're generating so much data, right? Every time we move our phone, right? There's a stream of data that is being generated over the wire of broadband, right? And somebody's storing something in some database, right? And we're generating, lots and lots of information, lots of data, more than we could ever possibly process, right? And we need to store it somewhere. We need to make sense out of the data, right? We need to data mine somehow and retrieve and aggregate and summarize and discover, data mine the data so that it's not data anymore. It's information, right? It's wisdom. It's meaningful. It's new relationship that we weren't aware of before, right? So MongoDB is designed for that kind of new world, right? That where we have this big data problem, right? Where we're generating so much data that we want it to be geographically relevant, right? We want it to be distributed. We want it to be redundant. And also we want it to be stored in a format that is friendly, right, to the type of application that we're building. And the biggest growth in applications today are, web applications that exchange data in JSON format. Right? So why not store that data already in a format that is friendly to the applications that are using that data, right? So MongoDB allows us to store data natively in JSON format, right? Store it in JSON format, retrieve it in JSON format, query it, right? Manipulate it, right? In JSON format. It doesn't provide many of the things that we expect or we've come to expect in a database, right? Such as joins, right? Where you reaggregate and reconstitute data from having split it into several collections or several tables, right? We need to do that programmatically. It doesn't necessarily provide schemas, right? That we've come to in relational databases, right? Instead, you are free to store whatever you want in any schema or any data types or any collection or combination of properties and values, name-value pairs. It's just basically just valid name-value pairs, right? Each object could be its own schema. Not that you would want to do that, but it doesn't enforce anything on you, right? It's whatever you want to store. If you're creating objects and you're storing objects, well, that's what it's going to store. Okay. Some of us might cringe at that, coming from a relational database world, but it's somewhat liberating. But to put some measure of order in this, otherwise something that might look like chaos, we're going to be using Mongoose. Mongoose is a library it's a high-level library that interacts with MongoDB, right? That allows us to get back a little bit of what we're familiar with in relational databases. So, for instance, one of the things that Mongoose introduces is schemas, right? Not schemas at the database level, right? These are schemas at the application level, right? These are more like classes more than schema, where you have a chance to declare their data types, right? And also relationships between the schemas, between the entities, right? And then Mongoose, as you create and you retrieve and you update data, these are validated against the schema, right? Unlike MongoDB. MongoDB will not validate anything, right? If name used to be a string and now name is an integer, MongoDB doesn't care, right? It's your business, whatever you do with the property name. Okay, it will store whatever you give it, right? With Mongoose, we'll get back a little bit of that sanity, right, of validation and enforcement of certain, of data typing and strong typing. So we'll spend a week talking about MongoDB and schemas and models and how to query and update and delete things on MongoDB. In the 5th week. In the 6th week, we're going to introduce Passport.js as a mechanism that allows us to standardize how we manage user identification, right, and user management, right. This will allow us to add the ability to log ourselves using just username and password, or log in using LinkedIn or Twitter or Facebook or Google accounts. Okay. It allows us to standardize how we can interact with all these third-party authentication authorities. Okay, and then later the last topic is somewhat of a filler topic in that there's no assignment associated with this last topic, which is dynamic server pages. This topic is actually where you might be more familiar, right? Things that you have already seen. Right? If you come from a PHP world or a ASP or a JSP world, this is where you would find yourself more at home. That's why I left it last. You can do everything you can do with those other frameworks. You can also do it in Node.js, right? Instead of being called JSPs and ASPs, they're called EJS, embedded JavaScript. You can embed JavaScript in pages, right? And you can dynamically generate content using embedded for loops, embedded if statements, and while loops, and whatnot, right? Just like you would expect any other server-side rendering engine. Okay. The final project, and although I'm listing it here, you should be working on the final project all throughout the semester, right? The expectation is that as you complete an assignment, you immediately start reusing what you learned from that assignment and say, ooh, how can I use this and implement towards my project, right? So this week, well, this week is for both of them, right? For assignments and projects. But next week, when we start looking at HTML and CSS and responsive design, right? You should start applying that. The login pages and the registration pages and the profile pages, right? You should, hopefully you can just grab that, right, and start designing your pages for the project. Okay, don't leave it to the end. It's really, really fast. The semester goes by really, really quick. Okay. The project will be due on the 26th, right? That's the last day of classes is the 23rd. Okay, but the project is due that Sunday. Right? We'll start grading on Monday. That's the week of the exams, right? And so we're not going to meet that last week for the exams. So instead, the TAs and myself are going to be busy, very busy, grading. So we're going to have very limited availability that last week. Okay. Any doubts that you have with the assignments or the project, will be very available up until that Sunday, right? That Monday is going to be crazy, right? It always is. Trying to get all the grades in and grading everybody. It's a really grueling experience on our end. So that week, we're just going to close ourselves and not be available for anyone. Usually we take one of the rooms in on West Village, right? We buy pizza, we all get together and just grade all week, right? And we'll have very limited availability. So please have everything ready for that Sunday, all right? Because I need to have grades by Monday, 4th of July. Wait, is that right? That makes no sense. I think that date is wrong. Anyway, that's following Monday. Well, every okay with the agenda? Sense? Questions? 7. So we started what? 5:30, right? 5:30. So we are at the almost hour and a half mark. So let's take a break, and then we'll come back right after these messages.
Yes, so actually I didn't class. So I'm from engineering department. So there's a switch students there. I still really only take books.
Okay.
So I talked to some like professor in the CS department. I never get the response from.
Who would you ask?
He's a coordinator, associate coordinator from the CS department.
Do you know the names? You should speak to Richard Rosala. Richard Rosala. Yeah, so email him and oh wait.
And the class also is tomorrow. That's full.
Yeah, it's full.
So
It should be full.
yeah, it's flat.
So we have a 50 maximum cap. We only have only 50 people in the class. So the option is wait and see if somebody drops. Well, somebody always drops the first week and register for the course. The other option is that there's still seats on the undergrad course.
Oh.
It's the same exact material.
Okay.
So you would be graded as a graduate.
Oh.
You're a graduate, right?
Yeah. That's
It's the same exact material.
okay. Awesome.
We do say to the undergrads that they have a couple of things that are a little easier, okay, that are optional. are required for the graduate students. So you would be graded as a graduate.
Okay.
But so that you need to ask Richard Sala
So
if he would allow you to do that. You register as a 4550, but get credits as a 5610.
Oh. Okay.
It has been done. It has been done before.
Oh, really? Okay.
Well, I know that has been done the other way, where undergrads have taken graduate courses.
Well, that makes more sense. It's, if,
So, but I don't know. So, I don't know if they allow you to do it in reverse.
okay, I would definitely.
I think so.
I would definitely.
I would ask.
But
we have a cap, a hard cap at 50. We can't let anybody more than 50
okay.
in the class. That's for a university-wide policy.
So if that doesn't work, and I still really want to learn the material, do the assignment, or even the project, and I still do it. But
that's fine. Are you in Piazza? Oh, you're not in Piazza, right?
Yeah, I don't really understand.
Yeah, so add yourself in Piazza here. So you get all the notifications. So type your email.
Okay.
Okay, so now you can participate on the chat. You can see all the assignments. You can go to the website and you can do all the assignments with everybody else. All right?
Thank you so much.
Okay. But you're not gonna get it if you don't enroll. You're not gonna get credit.
I mean, like, still learning process.
Yes, right.
Yes.
Yes. All right. Let's continue. All right, so this is as I was telling you earlier, this is the website for the course. It's available from Piazza, and you have already been invited to Piazza, yes? And on the left-hand side, you see all the different modules that we're going to be covering throughout the semester. There'll be as many modules as they're listed here on the agenda. Right? So there'll be a development environment. That's where we are this week. There's user interface development. That's going to be second week, third, fourth, fifth, sixth, seventh. Yes? So each module each week, as opposed to each module every 2 weeks. So yeah, I don't know how you know. So it's tough. It's tough. But the first one here, course videos. These are videos that of me recording. Have been recording all the lectures. I usually record all my lectures, and they are available here at the end when the lecture ends. Right. So I record them up to YouTube. I add them to a playlist, and the playlist is then included in here. I have one for each section. One for CS4550. That's the undergrads that we meet Monday, Tuesday, Wednesdays, and Thursdays. And then I have the other one that it's being recorded right now on the right-hand side for 5610, which we meet on Tuesdays and Thursdays. Yes? I'm using the same agenda. So what I'm going to try and do is that today I will cover what I covered on Monday and Tuesday for the undergrads. And on Thursday, I'll try and cover what I cover on Wednesday and Thursday. Mostly for me, just to keep my head straight and sane, so I don't have 2 sections going on each at different paces. The undergrads have exactly the same material, exactly the same assignments, or their assignments, some portions of the assignments are optional for them. So for instance, the web APIs is optional for them. It's not required that they connect to a third-party API and interact and whatnot, right? But it is required for the graduate students. Okay, so there are several of these things that I mark them as optional for the undergrads. If it's not marked optional for the graduates, I don't think anything is optional for the graduates. You should just go on and do it. All right. So you can see all the videos even from last semester, spring, and even fall and whatnot. They're all here, available here. And then these sections down below are not yet available. I'm still tweaking them so that you know, specifically for a shorter amount of time, I'm tweaking them a little bit, and I will make them available a little later. So development environment, that's where we are right now. The focus of this week is to set up a development environment. Okay, and this section should guide you through doing just that. Right. So each of these modules on the left-hand side, when you click on it, on the right-hand side, you get an overview of the module. You get a course map of where we are in Module 1 and the various different technologies that we're going to be working on in this particular module, the IDE, Node.js, MongoDB. We're introducing all those, setting them up. Then in the lectures, I have quite a few videos that are specific for that particular topic, right? I here in the first video I talk specifically about Node.js. In the next one I talk about MongoDB and so on and so forth. You know, setting up all these tools. Okay, I encourage you to watch these videos before coming to class, right? So that you have questions and you have doubts. We can talk about them here in class, right? So these videos are a little more polished, right? These are recorded in the studio, and they're more targeted as opposed to the videos that are recorded on YouTube. That's me just speaking, you know, in a lecture, right? Now the lectures are recorded there for your convenience. If you want to revisit the material at your own pace, if you miss something, if you need to you know, review something, they're not meant to replace the lecture, right? I would still encourage you and expect that you are physically here. But if you must miss a class, you know, you can feel confident that the lecture will be recorded and available for you. Okay, but nevertheless, I expect that you do come to all the lectures. All right. Also here in the top level tabs, you'll notice that there's different sections, right? Different videos for each one of the different topics. So there's some videos for OpenShift, a couple more for Git. There are a couple here in OpenShift that I recorded at the last minute, and some of them do not have voice, they don't have sound. It's just me very slowly demoing something, right? So I know they don't have sound. I know they don't have audio. Okay, so just there's a couple here on the OpenShift that I added, and the audio was not recorded. The last tab, right now there's just one assignment for this week, and I think that's what I'm going to do. I'm just going to have just one assignment, and that's it for a week. When I have more time, I usually have smaller assignments and spread them over a longer period of time, but we can't do that in a 7-week. So I'm going to condense some of this, right, into just one single assignment. So this is the assignment this week. You can read it here, or you can expand it and view it on Google Doc. And don't worry, you can't edit it. So the first assignment is to set up the development environment. And so this is going to guide you step by step how to set up your development environment. Okay. First of all, you're going to need to download a couple of things. One of them, you'll need to download Node.js, right? You're gonna install Node.js locally on your machine so that you can run the server locally, right? You can download Node.js from this website, right? So if you click on download and install Node.js, if you go there, you can install, download the latest Node.js. Maybe stick to just version 4.4.4, although we might be safe with 6.1. Actually, if somebody wants to experiment with 6.1, that'd be okay. I don't think we're going to be using any of the advanced features of Node.js, so we should be okay, right? Especially if we're running it locally on our machines, right? But once we install it and deploy it on the remote machine, that's where I might be a little worried. But I don't think we're going to do anything particularly weird. That we're going to stay within the confines of the common use of Node.js. So you should be okay with either one. Anyway, when you install it, it'll auto-extract, it'll auto-deploy, and it'll copy several tools on your path, right, in your path. In particular, we're going to be interested in two of them. One is the Node.js executable, right, and the other one is npm. So at the command line, you're going to be able to run these two executables, right? One is just Node. Okay, Node is very similar to other interpreters, right? Like Java, right, or Python, or whatever, right? They expect an executable file, right? In this case, it would be a JavaScript file, right? So if you provide a JavaScript file, right, Node, and maybe hello.js, right, it will execute that JavaScript file, right? And in there, you could put everything you would expect to be able to do in a JavaScript executable, right? You can do for loops and if statements and functions and console logs, everything you could possibly do with JavaScript. Actually, not everything, right? Because we're running on the desktop, right? We're not running in a browser. So there is no window, right? There is no DOM, okay? There is no alert boxes, no dialogues, right? This is strictly running at the console, right? So all that is gone. We don't have a UI, right? This is all server side, okay? But everything else is there. But there's a lot of things that are here that are not on the client, on the browser. We can access the file system, which we couldn't in the browser, right? We could do network connections to anybody we want, right? As opposed to browsers. Browsers limit where you can connect from a JavaScript, right? Cross-domain scripting, right? We don't allow JavaScripts to go anywhere, do connections, network connections anywhere, right? We can connect to databases. We can do all sorts of things that we could not do on a browser, right? But because we're running on a desktop machine. So that's one of them. We're going to be using Node. That's one of the executables that you get when you install Node.js. The other one that we're going to be using quite a bit is npm. npm stands for Node Package Manager. Node Package Manager, right? And Node Package Manager allows us to install other features of Node, right? Other modules, other libraries that we're going to be using throughout the semester, right? In particular, we're going to need the Express. That's the E in mean. We're going to need the Express library. We need to npm to install it. You're going to do something such as npm install Express. All right, we'll get to that in a minute, right? And that is going to connect to the npm. There's a repository. There is a repository of all these libraries. This will connect to the repository. We'll download or recompile for your local machine and install the latest of that for that package. Yes? Right? So yeah, we're going to be using npm quite a bit. So yeah, you install it, and now you have those two. Very good. So yeah, so that should go smoothly. The next one is setting up MongoDB locally, right? So MongoDB, that's going to be the database. We're going to be running the MongoDB, running it locally on our machine, right? We're going to do all the development locally on our machine. Once we're happy, we're going to commit our changes to a GitHub repository. We're also going to commit and push our changes to an OpenShift remote server, right, to deploy our changes so that they become available on the web, right? Development is going to happen locally. So we're going to download MongoDB. So you're going to go to MongoDB from here, and you're going to download MongoDB for your, oh, that's not the enterprise. I didn't want the enterprise. You can download for your particular framework, right? Apple, Mac, or Windows, Linux. Download the latest and install it locally on your machine. It's a zip file, right? So you'll need to untar it, right? And typically it'll auto extract in a folder. On a Mac, typically we move that folder, we move it into user local. Okay, that's a very common place to move it. You might need administrator permission. So you might need to do a sudo to move the folder into place. Okay. Under that directory, there is a bin directory. So it's going to be under user local, and say you call it Mongo. So under there's a directory. There's a bin directory, right? We need to add that bin directory to the path so that you can execute, right, all the executables in that bin directory from anywhere in the terminal. Okay. So in that bin directory, there are two executables in particular that we care about. One of them is MongoD. The other one is Mongo. These are two executables. There's a whole bunch of them, but those two are the main ones that we're going to be using, right? MongoD is to start the server, the Mongo database, MongoDB database. Okay, that's MongoD. Whereas Mongo, that's a client, right? So that you can connect to the server, right, and check out what databases there are, what collections there are, what's the data, you can query it, you can update it. It's a client. Yes? Client to the local MongoDB running server. Everybody okay? So here I ask you to download and install, move it into user local, and MongoDB, when it runs, when you first run it, okay, it's going to look up for a path, a directory, where to store all its data, right? The default location that it expects is this file, is this directory, /data/db. So it's right off of your root, right off the root of the hard drive, right? You're going to expect a folder called data, and in there another folder called db. Yes? If it doesn't find it, it's going to complain. It's not going to create it for you, right? You need to create it yourself. All right? You can change the location if you don't want it there, right? But then when you start MongoD, you need to always tell it where it is, right? So it's easier to just create it off of the root /data/db. You might, again, if you're on a Mac, you might need to use a sudo, right? Sudo make directory blah blah blah. Yes, right? Okay, here I'm assuming that you created that directory here /user/local/mongo. So I'm asking that this bin directory here, this bin directory, to add it to your path, right? So that you can execute these executables from anywhere in the terminal. Okay, so to do that, you're going to need to update your bash property on a Mac. Right? If you're on a PC, you'll need to go to your system environment variables, right? And to the path environment variable, you're going to have to add the path of where that bin directory is. But on a Mac, you need to do it here in the bash property file. There, you're going to add a line that looks something like this: export path equal the path to the bin directory, and then colon $path. Yes? Right? You'll need to restart the terminal, otherwise it will not read it. Okay. So once that is done, you can test that it starts by typing MongoD at the command line. You type MongoD, the server should start. Again, on a Mac, you might need to do sudo MongoD, right? Because it's going to try and access /data/db, which is at the root, and to access that directory, it needs administration privileges, right? So you need to run it with sudo. And it looks something like this: MongoD starting yada 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 yada. That it's looking at this path of where it's going to store all its files. That's going to listen at this particular port. This is a standard port where MongoDB typically listens at, right? It's a 27017. And if it's successful, at the end, it should say waiting for connections on port 27017. Okay. All right. So typically, all our applications are going to be database-driven applications. They're going to use the database, right? So before you start the server, right, typically you should start the database first, right? Otherwise, the server, one of the first things that it's going to do is going to look to connect to the database, right? If it doesn't find the database at 27017, right, it's going to complain, it's going to crash, and do all sorts of things, right? So, so you should first start the database, and then start the Node.js server. Okay, right? Or you can set up MongoDB to run as a service, that too, right? That it starts up every time, but I'm not going to cover that. All right, so there you have it. That allows you to get started with Node.js and MongoDB. Next, you'll need to set up a Git, right? Which most of you probably already have a Git account. Yes, it's okay if it's private, but that you're going to create, you're going to need to invite the TAs and myself as collaborators, not to your account, but to the repository. You're going to create a repository for this course, right, where you're going to make all your source code available to the TAs and myself. Okay. First, you're going to have to install a Git client locally. If you're on a Mac, you should already have Git. Right? If you're on a PC, you'll need to download a Git client. Right? Any one of these is fine. All right. What else? So I created a template project. I created a template project that should get you started, get you going with a minimal, right, a bare bones a server that can be executed locally on your local machine and is also friendly with the remote server that we're going to be using, OpenShift. Okay, so I'm going to ask you to please either fork that template, right, onto your own Git, or you can clone it, right? Just clone it down and then push it up to Git. So to clone it down, what I suggest is that you create some directory local on your file system, perhaps in your home directory. Okay. Here, I'm assuming you called it Summer 2016, right? And that's where, because you have other courses that you're working on. Under you're going to create in Mac the tilde means home directory. Okay, so in there you're going to create a directory in there. You're going to go into that directory. Then you're going to clone. You're going to clone down the project, the template project, or you can fork it. Either way, it depends up to you how you want to do it. You can clone it down. That's the That's the that's the URL to the template, right? Webdev template.git. This is going to clone down and going to copy all the source code from that repository onto your file system. It's going to create a directory in there inside of Summer 2016. If you do an ls, right, it's gonna list WebDev template. I renamed it. To WebDev, or you can rename it to whatever you want if you don't want to call it that way. Maybe you want to call it CS5610, whatever you want to call it, right? I renamed it to just plain old WebDev. Once in that directory, you do an npm. It's this one, right? It's npm we just have here. See that? npm install. Just npm install. That's it, right? What this is going to do is that the project has a file that describes the project, right? Describes all the dependencies, right? For instance, it says that it needs Express, right? It needs the Express library. The Mongoose library, right, to connect to a database, right? So install is going to open up this package JSON. It's a JSON file that describes the project. Is going to install all the dependencies, right? Let me show you. If you go to this URL. Okay, you'll see the project. The project is very, very simple, right? It has almost just a couple of files in here. And the file I'm talking about is this one, package.json. Package.json is a very special file, right? It's a file that Node.js uses, right, to describe projects, right? One of the things that is listed in there are libraries that this particular project depends on. Right? It depends on, in particular, these 3 libraries, right? Or just 2 of them. So Express is the library that allows us to, with 2 or 3 lines of code, create a server. And just with 2 or 3 lines of code, we have a running server. Okay. With Mongoose, that's another library that allows us, again, with 2 or 3 lines of code, be able to connect to MongoDB and start inserting and selecting and reading and updating and deleting and interacting with the database. Okay, so those are 2 libraries that this template project, I'm using it so that I can test whether you were successful in installing your environment, your development environment. You're going to test whether your server is running. You're going to test whether your database is running. Okay, that you're connected to it correctly. Okay, right? What else? Okay. All right, so it's going to clone it down, and so when you type npm install and don't tell it what to install, like over there we said npm install Express, right? Express is known, it's a key. It's the name, it's a unique name of one of thousands of libraries, right, that are available in the npm repository, in Node's package management repository, right? It's a very famous, very, very popular module. If you don't say anything, you just say npm install, what it's going to do, it's going to look for package.json. Right, package.json. Also, it's a very standard name, right, in the Node community. But it's going to open up this file. It's going to look at the dependencies and says, I need to install Express, I need to install Mongoose, and I need to install a body parser. It's going to bring down all those 3 libraries. It's going to compile them all, right? It's going to install them all inside of a very specific directory. It's going to install it. Right, under node underscore modules. Okay, so right here, so in this folder that's going to copy it and clone it down, you're going to see an additional folder in there called node_modules. I think I did it here. Let me see. Oh, did I do it also? Yeah, CD Summer. Yeah, there it is. See, I cloned it down, right? And this is the local folder that I have. You see package JSON, public, server.js, test, right? And see node modules, right? So that is, if I blow it away, how do you remove a directory? What is it? There. Sorry? RM? Space or hyphen? Space hyphen. R? Just like that? Okay, there we go. All right, see, so node module is not there. So if I say npm install, right? So it's going to bring down all the libraries, right? Including Express. There we go. And we say ls. There we go. We have node modules under there, right? And under modules, we see that all the things that it downloaded locally, all the libraries that it needed. Okay. So that command npm install exactly what our remote server is going to do, right? When we deploy this to the remote server, right? The first thing that it's going to do is going to read that package JSON. It's going to run npm install, right? And it's going to read that package JSON. And it's going to install all the libraries, right? So these node modules, right? This node modules directory is really unnecessary, right? We don't need to keep that directory around. We can always recreate that folder, right, using npm install, right? So you'll notice that there's tons and tons of libraries under there, right? That we don't need to keep that around. We don't need to put that in source control, right? Because we can always recreate it using npm install, right? So to make sure that that folder is not added to the source control, right? To Git, right? We created a .gitignore, right? And .gitignore says ignore the folder node modules. I don't want that in the source control, right? That is only meaningful locally in your local environment, right? It's not over here. It's a Mac, so I have the Mac versions of these libraries, right? If I push it to the server might be might be a Windows machine, right? It would have to. Those node modules would be completely irrelevant. Why even store it in the repository? See that? Right, so every time we install, the remote install all these libraries. Also, IDEA here, it's another folder that the IDE, we're going to be using WebStorm as the IDE. The IDE creates its own folder for its own configuration, and we don't want to store that in the repository either, right? So we have .IDE in the gitignore. What else here? Okay, so npm install. All right, so once we install it, we can finally do node server, node space server.js. Right, and server.js is a JavaScript file. We say node space server.js. It executes that file. And in our case, let me see if it. Okay, there we go. So it's running. Oh, it's not. What's it not expecting? Oh, so see, notice that it's trying to connect to the database, right? And says, oh, the database is not running. Right? So let's start the database. So let's say Mongo D. But I noticed that it complained saying that it wasn't able to have access, permission denied to a cup. Wait, already running? permission denied. Is the MongoDB? I think it could not access data DB. Let's see. Sudo. Okay, it's listening. All right. So if we try to run node server again, all right, it doesn't complain this time. So if the server is running, it is waiting for incoming requests, presumably at localhost. So let's try and access that. If we go to localhost 3000, it comes up with this, right? So this is what your default template homepage should look like, right? This homepage you're going to be graded on, right? So you're going to have to modify this template homepage to look spectacular, right? I just have a couple requirements. One that looks spectacular, and the other one is that you keep these links. Put them anywhere you want, okay? But they should be clearly visible and clearly accessible to the TAs and myself, right? Because it's going to give us access to your project, right? It's going to give access to your assignment. It's going to allow us this weekend or on Monday to grade this particular assignment that you have access to the MongoDB, and also a link to your GitHub, right? Which is going to have the source code to everything. Okay. All right. If I click on project, it's going to go to an empty homepage for your project. This is your homepage for your project. Okay. So here you're going to do whatever you want. Well, within the confines of the requirements that I will stipulate. And in parallel, we have assignment.index, right? This is where you're going to be doing your assignment starting next week. Right? The first assignment, well, the first assignment is setting up your environment, but the assignment where you're going to start building is going to come out on Monday. Maybe I'll make it available earlier. And here's where you're going to get started. Okay. All right. The directory structure is what I mentioned earlier. So it's the directory of the assignment is under the public directory. See this public directory? That's where all the public content is going to be. All the static public content is going to be, right? All your HTML files, all your CSS, all your JavaScript, all your images, right? Anything that you want to make publicly available from the server's point of view, right? You're going to put it inside of this public directory. Anything outside of the public directory is not going to be publicly available, right? So that that package, that Git, that task, the server, none of that is publicly available. Meaning, it's not accessible from the browser. Nobody can browse to these files. Only to the files inside of public. So in there, that's index. That's the home page of the website. Right, the entire website, and that's where you have links. You have links to the assignment and your project. So all your work for the assignment should be here under assignments. Right now, it just have index.html. That's all it has. Okay, and project too. The only thing that it has is project, but you're going to be adding quite a bit of content into these directories to be there. Index is a very special file. Has a special name. Right, it's a default name. It's the default file that gets served, right, if you don't specify any file. Okay, so notice if I go here and I notice that I didn't specify index. See that? I didn't specify index, right? And if you don't specify, what you get is index. That's what you get. Same thing if I go to project. I have project, but if I take out index, I also get index, the content of index.html, right? Because it's the default. If you don't ask for anything specifically, that's what you get, if it's there. What else? Project, assignment. All right. I did want to cover, let's see. So to try out your application to see if it's running correctly, we're going to go into test MongoDB, right? So this is a trivial Angular application, very, very simple Angular application that just posts data to the server and retrieves data from the server just to test whether your MongoDB is running correctly. Try it out locally, see if it works locally. Try it out when you deploy it on OpenShift, see if it works there. That's what we're going to be doing next week, starting on Monday, to see if it's running for you. Okay? We're just going to test some sample test messages, see if we, we're going to try whatever, add. So that's going to the database, storing the database, and then retrieving it again and displaying it. And we can also remove the messages. Okay? Especially if you write something inappropriately. Okay, what else? All right, cover that. We're gonna try your MongoDB. We're gonna try if it creates the messages. All right, Git. So now you have a local Git repository, right? Because you cloned one, right? You cloned it from my repository. Okay, you have a local Git. But I need you to have it in your own Git, right? Not mine. You need to push it to your own Git, and you're gonna be maintaining two Gits. One is GitHub, right, which is publicly available and it's free and it has a lot of statistical analysis, a lot of fancy ways for us for the TAs and myself to track your progress throughout the semester. And the other Git that you're going to be maintaining is the OpenShift. OpenShift has its own Git, right? It's not as fancy. It's a very bare bones Git. Right? It does whatever Git does. That one's going to be used for deploying your content, deploying it so that it's available to run on a server, on the remote server. So the Git that you're going to be, the public Git that you're going to be creating is in GitHub. You're going to go to GitHub, and you're going to sign up. You're going to sign out. You're going to sign up for GitHub, unless you already have it. Who has one already on GitHub? Right, so most of you do already. Great. Create a repository. If you want, you can make it private, but I think you have to pay for private. Although I've heard that if you have an EDU account, you don't pay private accounts. Is that true? Yeah. Okay. So if you want, you can make it private, as long as you invite the TAs and myself and make us collaborators. What this is going to allow us to do is, if you run into an issue on Piazza, please, when you ask a question that you run into, that you're stuck on something, always provide us with a link to your GitHub account, to your Git repository, or even better, to the file where you think the problem is. Okay, because you have done extensive debugging, right, and you have narrowed down the problem to this particular place, but you're stuck and need our help, right? So, provide, when you ask for something, provide a link in GitHub for the file that you've identified, and we will try and help you. We will clone down your Git repository, right? We'll try and run it locally on our machine to see what's up. If we find a solution, we can commit a solution and post it back into your Git repository. Okay? It'll be a very nice way to collaborate and help you out. All right, but if you don't provide the link, we'll be missing 2 or 3 back and forth asking where you think the problem is, and it'll just make everything so less productive. Right, so please provide us with as much information. Help us help you. All right. All right. Awesome. All right. So create a GitHub repository. Just for us to keep track of who you are, the repository, if you could name it last name, first name, web dev. Or should it be web dev, last name, first name? I think it'll be prettier if it's just web dev, last, first, right? Who prefer? I don't care. Either one, that's fine. I do want to be able to, from the web repository, know who you are. Because I'm going to clone it down. I'm going to have 50 repositories, right? And I don't want them all called web. So put your last name and first name so I can know exactly who you are, and I can distinguish you. So for me, it would be something like Annunziato Jose Web Dev. So it would look, so okay, so I have it a clone. Once you create a GitHub repository, we're going to push all this new repository, this what I have locally, we're going to push it to the GitHub repository. So to do that, we're going to create a remote, right? Git remote at, we're going to call it GitHub, so it's clear that this is the repository that it's connected to this GitHub account. And then I'm going to push GitHub to master. I'm going to push the master branch to GitHub, right? So it's going to copy what's local onto the remote GitHub account. Everybody okay? And then include the TAs and myself as collaborators. Yeah, so verify that the code is there. Invite us. My username on GitHub is just Giannunzi, right? If you want to invite me, right? The TAs will post their accounts online on Piazza and let you know who they are. So invite them as well. All right, so now OpenShift. So OpenShift is where we're going to be hosting our application, right? Our websites. Okay. So you need to go to OpenShift and create an account. It's free. They have a free plan where you can have one server, one database, and another tool, right? Like a client, like a database client. It's free. I think it's up to like 500 megabytes of data, right? After that, you can upgrade to whatever plans you want to. If if your website is very successful and it needs much more bandwidth, you can certainly upgrade. It's by Red Hat, so they have quite a few tools, Red Hat tools, to manage your OpenShift account. Okay, those tools you need to install locally on your machine. And here's a link on how to do it. You'll need to install Ruby, right? First, on a Mac is very easy. You just say. On a Mac, it should be already installed, I believe, right? And to install the tools is very easy. On a Mac, you could just say gem install RHC. RHC is the name of the tool. You'll install it locally on your machine, and you're good to go. On a PC, you first need to install Ruby. You won't have Ruby on there. Anyway, read through this, and it'll walk you through installing those. Those tools allow you to, for instance, do remote debugging. Right? So for instance, if the server crashed, you can read the logs. You can tail the logs, right, as the server is running. If you're outputting content from the server, you can see the logs right there and live. So it's nice. Also, if there's a problem, any exceptions will be on the log, so you can see what's going on. Then once you're in an OpenShift, I'm gonna log in. Once you're in OpenShift, at first this is going to be empty, right? It's going to say you want to create a new application, right? You don't have any applications, so there'll be a big button, a big blue button that allows you to add applications, right? You're going to go in there, and you're going to have a whole bunch of options of what you want to host. You want to have a Ruby on Rails, you want to have a JBoss server, what do you want, right? So we're going to be using the latest version of Node, which is way down here, Node.js, right? Node.js. So you click on that, and it's going to install a Node.js instance. Give it a name. It'll be whatever username you had, Giannunzi, and then the name of the application should be something like WebDev, right? WebDev, and then your username or whatever name you want to give it. Okay. And just say create application. It'll take a minute or so to install and get it started. After you do that, after you do that, you have your application there. You can click on it, and you're taken to the dashboard of that particular application, right? And there's nothing there yet. It's just an empty Node.js. There's nothing there. Oh, I'm sorry. No, there is a default application. There's a default set of files in there, but we don't care about what's already there. You'll need to install MongoDB remotely also. And you'll have a link at the bottom, something like this, where you can say add MongoDB, right? So you click on that. It'll walk you through the installation, the remote installation. It just basically configures MongoDB. It's already running. It's a shared MongoDB instance among several users, but it sets it up, and then it tells you the username and password for your database. Copy that username and password somewhere, right? You might need it later. Unlikely, but you might need it later. Let's see, what else? All right, so once you have MongoDB running, okay, what we want to do is that we already pushed our content to GitHub, right? It's already there. Now we have to push it to OpenShift, right, and deploy the server of OpenShift. One of them in GitHub is for our convenience, the TS convenient and myself, to keep track of your progress. Right? GitHub has all these really cool graphs, on what, how have you been working, if you have been consistent, if you've just been waiting till the very last night, right? You have these very steep peaks, right, of work, or you have a nice, smooth, consistent work. That you keep do a little bit every day as opposed to waiting to the very last minute, right? So GitHub gives us a very nice graph of your progress, okay? And that'll give us a little bit on how much you have been working really hard in this course. Instead of the Git, OpenShift also has a Git, but it's nowhere. It's very bare bones, right? So we ask you to maintain both. One for grading for us, the other one is where you're going to be deploying, right? But at all times, they should contain exactly the same content, right? They should always contain exactly the same content. So whenever you push to one, push to the other, okay? Anyway, so we already did it to the GitHub. We're going to now push it to our OpenShift. So inside of our web dev directory, we're going to log in. We're going to log in into OpenShift, right? Using the RHC tool that we created earlier. We're going to say setup, RHC setup -L, meaning I want to log in, and the email that you use to create the OpenShift account. Yes, it'll ask you to log in. It'll ask you for your password, right? It also asks you if you want to create an SSL key pair, private key, right? And it'll upload the key to the server so that it'll have secure communication between the OpenShift server and your Git repository locally. Okay, it'll ask you, do you want to create one? You say yes. You want to use the remote server? You say yes. I want to use the remote server. In OpenShift, that's where I want to server. It's not I don't have an OpenShift server running on my machine. I have an OpenShift server running in OpenShift. We're going to use that one, the remote one. Basically, it's yes, 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 yes to everything. It's the default installation. Yes, yes, yes. In particular, of interest is this right here. See that? Right? That is the GitHub URL of the remote Git for OpenShift. Okay. You're going to need to copy that. You're going to need to copy that so that you can now add it as a remote, as a Git remote, right? It's OpenShift SSH. There's something really long, right? Which is this URL over here, this really long URL. And you're going to add it as a remote, and then you're going to add everything in Git, right? You're going to commit our very first publish into OpenShift, and then you're going to push to OpenShift, right? This is going to stop the server. The server will be unavailable. Okay, it's going to stop MongoDB, right? It's going to copy your files to the remote Git repository. It's going to run npm install, right? So it's going to look at your package.json file, right? It's going to install all the libraries. It's going to restart MongoDB. It's going to restart the server, right? It'll take about a minute or so. Okay, so in that time, your server will be temporarily unavailable. Okay. Also, these servers are not, since they're free, okay, they do go to sleep when they're long time span of inactivity, right? So from time to time, if you visit your website, you'll see that it's temporarily unavailable. Give it a minute, give it a couple seconds. It'll wake up, right, and then the server will restart, right, and it'll be available. So don't freak out if you see a server's temporarily unavailable. If it doesn't restart, it's because something went wrong in your server, right? And then you'll need to debug it and do a tail or something, right? And look at the logs. If something goes wrong, you can tail. You can do RHC tail, right? This will display the log, right? Display the log. And you can say, you have to provide the name of the application that you gave it, right? I named it webdev, -a webdev. You can restart the server. So before you do anything, try to restart it right here. You see this? Start the server, right? So you can do a tail and then restart the server, and then the logs, you'll see the logs as it pass by, and if there's any errors, you'll see it in the logs, right? Typically, it's because either MongoDB wasn't running and it couldn't find it, right? Or one of the common things that I see very often is because you installed a library locally on your machine, right? But it's not in package.json, right? So it's installed locally on your machine. Your local Node.js is happy, yes, because it finds the library. It's installed locally. But when you deploy this, because it's not in your package.json, but it's in your source code, you're referring to a library that doesn't exist, right? Node.js freaks out and says, oh, that library is not installed, right? And so it can't continue, right? It dies saying, can't find library, yada, 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 whatever, okay? All right, we'll talk about how to resolve that issue a little later. All right, so so once the server is running, you should be able to access it remotely. Webdev - your username.rhc cloud. Okay. Yes.
So the first thing when we are adding an application, what URL should we be putting into that application?
You can choose whatever you want. It has to be followed by your username. Right, so it makes it unique. Right? So your domain is .rhc cloud, but it prepends for your username, right? And in front of that username, you can choose whatever you want, right? I suggest you just call it webdev. Okay, just webdev. All right, and finally, you'll need to install an IDE, right? And I would like to standardize around WebStorm. Okay, WebStorm is it's a very common IDE that web developers use out there in the industry. It's free for NEU.edu accounts. So when you're going to download this, when you create an account with them, right, using your Husky account, right, and when you download it, you're going to ask that you want to register your copy as a license, right? Provide the Husky account, log in with there, and it'll be free. It won't bother you. Okay, it's a very powerful IDE. It lets you run Node.js right within the server, within the IDE. You can put breakpoints on the server, so you can step through your code. Which is very powerful. You can see all the variables and watch and whatnot. Very nice. Okay. I do ask that you create a running configuration, so that you can start the server from within the IDE. You can always start the server by saying node space server.js, right? But that doesn't allow you to debug, right? And I know you're going to be doing a lot of debugging, right? So to be able to debug, you need to create a run configuration. Right? You just say, I want to use Node. I want to run server.js, right? And then you can run it right from within your file. You can start it in debug mode and then put breakpoints, right? And again, if you come for help, I would expect that you come because you've done already extensive debugging, right? You put breakpoints all over the place, right? And you step through it, and you have an idea of what's going on, right? And you've identified that it's in this general area, right? And then I can help you from there, right? But what I don't want to see is that you've made no effort at debugging this, right? I see no breakpoints anywhere, right? And you have no idea of what might be wrong, right? So please come with you having done some effort at debugging, right? And I'll do some debugging myself here as we work through this. Deliverables. So on Blackboard, we're going to be using Blackboard for submitting assignments, but we're not going to be uploading any source code whatsoever on Blackboard, right? All source code should be deployed, available on GitHub, right? At the end of the week, when you're done, that you're ready to submit your assignments, you're going to commit and push all your work, right? And on GitHub, you're going to tag. You're going to go to GitHub. Okay. So here's your code. You're going to go to releases, right? This is after having done a whole bunch of commits, and you know exactly what you want us to grade. You're going to go to releases. You're going to releases, and you're going to say. Are there any tags? Wait, why can't I create a tag? Oh, I signed out. Thank you. Okay, so you're gonna do a release. You're gonna say create tag, and for assignment 1, you're gonna use the tag assignment 1. For assignment 2, you will use the tag assignment 2, and so on and so forth. Right? After you tag, if you want, you can keep working. Right? You can do any changes you want. Right? Maybe we want to start already on assignment, the next assignment. Right? We're going to get ahead. It's okay. We can always come to your repository, look at the tag, clone down that particular tag, right, and run it locally on our machines and grade you whatever it was, right, when we create the tag. Yes, that's a great thing about repositories, right? Code repositories. You can always go back in time. Right. So in Blackboard, the only thing you're going to submit to us is the URL of where your project lives in OpenShift, so we can go look at it, in OpenShift, and also the Git repository, right? You're going to submit this to us so we can go and view your source code. Okay. And that's it. For each assignment, you're going to do the same thing: the Git repository and the URL to your homepage. The URL to your homepage. Okay, and we'll see the source code on GitHub. Right, we'll look for the tag assignment 1, assignment 2, assignment 3, and we will grade that. All right. All right. Any questions so far? Yes.
So if you're working parallelly on the project also, how does it go to OpenShift to the application? Because I think it only has 3 years.
No, so your project is going to be in the same Node.js gear, right? It's going to be just off of /project/assignment, okay? And we'll get to your project by clicking that link to your project, okay? All right. All right. I'd like to go over what we're going to be building as an assignment throughout the semester. So throughout the semester, we're going to be building an application, right? And your project should be in the same level of complexity as the application. Right? It should be somewhat in the same complexity. Right? And so let me show you the application we're going to be working on. Okay. All right, so this is the application. Let me run this. Okay, this is the configuration, right? Where I've already created a configuration that allows me to run a node, right? It's a node configuration. You can say plus. You can create a node configuration, and that's going to execute node. There it is, with this server.js. Server.js will be your server, which is listed here, right? Which is your, it's going to look just the same for you. So let me run it. And here I have, let's say localhost. Where's it listening to? I forget. 4,000? Oh yeah, okay. All right, so I'm going to look at it and inspect. Right, so inspect in a browser allows it to look at what's behind the scenes, right? A little bit of what the HTML, the CSS, the JavaScript that is implemented and it's running now in your browser. But what I'm going to do, I'm going to go into mobile mode, right? And this is how Chrome would interpret your content in a phone, right? Right. So and this is one of the first things I'm going to do with any of your projects, right? It should be usable in a phone. It should be nice, nice padding on either side. There should be nice spacing between each button and each element. Okay, good use of white space above and below on left side, left and right. Big areas for you to be able to click on, right? So to make it usable on phone. So again, phone, mobile first. Okay. Also good use of either tooltips or placeholders to give a hint to the user of what is that they can type in there, or an example of what they could type in there. In your project, you should be able to log in either with username and password, or any third party, at least one third party authentication, right? It could be Google or Twitter or Facebook. Here, I can use either one, Google or Facebook. Here, so definitely a login page. Also a home page. I don't have a home page just yet, right? But I will be adding a home page in a bit, right? So that home page should describe what your project is all about, right? And entice the user at wanting to either register and start using your project. Okay, a little marketing in there. You should be able to log in. You should be able to register. So let's create a user, Al. Password should not be displayed. Right? I should use the type password. There should always be a way that you can cancel whatever you want, whatever you're trying to do, right, and go back to where you were, such as cancel here. Also, the coloring should also somewhat be in relationship, socially what it might mean, right? For instance, red for cancel, or blue for something positive, or green for something positive, right? Or red or orange or yellow for something that might be dangerous or warnings. So here we have a profile. Notice that I cannot resize the page, right? Even though it's web. Right? If I'm not on a phone, I can resize, right? Which is okay, right? But if I'm on a phone, right, I should not be able to resize, right? So you should configure your web application so that it's not resizable, right? When you're on a phone, okay? Some things should be resizable, some things should not be resizable. If you're looking at an image, maybe that's okay. That should be resizable, right? Maybe if you're looking at a map, maybe that's okay. It should be resizable. But a form, being able to resize, that makes no sense, right? If you want to maybe allow to change the size, right, of fonts, maybe that's okay, but not by resizing. Maybe provide some mechanism, right, that allows you to set different font sizes, right? So each project that you're going to be building should have a login, a registration, a home page, right? It should be mobile first, right? You should have a profile page. Edit anything that is private, any private information, first name, last name, emails, phone numbers, addresses, things that are personal to me, right? That I might have the choice to make it public or not, right? I should be allowed to choose these things, right? They should be single page applications, right? So the page should never refresh, right? Should never reload an entire page, right? It should go back and forth to retrieve content. You can see the chatter in the network here as different content is being fetched. So for instance, if I click on websites, right, you'll notice that it went and retrieved a partial, right, this application list.view.html, right, went and you did an AJAX call to retrieve all this HTML and replace the DOM with this content. Also, you're going to be using AJAX to retrieve data from the server, right? So for instance, in this case, in the profile, it retrieved information about the user, right? It retrieved the data about the user, and the JSON that came back from the server, right, was used to populate the form, right? So in this case, I only have the username, but if and notice that it was retrieved using this query over here. In the header, we saw that it's a get, right? And that we use this URL over here, and this URL should be a RESTful URL, and we'll cover RESTful web services a little later. But it includes the fact that if we are reading data, it should be a get. Notice that it's a get, right? If we are instead updating, and we have here Jose or Albert Einstein, right? And we do an OK. Let me clear this. An OK, right? Notice that there was an AJAX call back to the server that we were updating data, right? So RESTful services use puts whenever they are updating data, right? They use get when they're reading, and they use put when they're updating data that is already existing and modifying something. Here we get an OK saying that it was successful. If we leave and then come back to the server to retrieve data with more data that I have now. I have first name, last names now, right? I have that information. And that data is used to dynamically populate the form, right? The form, the HTML that comes, never was populated. They didn't have any data, right? It came out blank. it's an additional call to the server to retrieve remote information to populate dynamically our content. Some other use practices is that if we are asking for data, typically data is, we distinguish between data and content, right? HTML being content, CSS, images, content, as opposed to data, right? And to distinguish the both requests, right? We usually prepend accesses to data with a namespace such as API /API, right? This is very common. Another very common one to use is /REST, okay, or /data, right? But the one that I've seen most used is just /API, right? Instead, if we're retrieving HTML, which we haven't, notice that we haven't retrieved any HTML. Let's go see websites. Another thing here in the profile is that typically profile should show me information that is private to me, right, or things that I can change about my private information. It also should allow me somehow access to data that I'm related to. Somehow I'm related to other things. I might be related to other users, right? I might be related to any domain object that I might have, movies that I like, right? Songs that I've heard, right? Blog posts that I've posted, right? Things that I've reviewed, right? Things that I have done, right? Things that are related to me. So the profile page somehow should give me access to things that I am related to, right? Right now, what I'm related to here are websites. This is the project that we're working on is on online phone-based IDE. So we're going to build an IDE, right, that allows us to build websites. Okay, that's the assignment. That's the homework that you're going to be working in parallel. And in parallel, you're going to be working on your own project. Yes? Right? Hopefully what you learn from the assignment, you can then apply to your project. Anyway, so I can reach websites from here. The websites that I've built, I don't have any websites. I haven't created any websites yet. It's a brand new user. Also, I'm going to be looking for consistency, right? Notice that my site is somewhat consistent. We're going to have this plus sign on the right-hand side, top right-hand side, typically meaning that I want to be able to add things, right? And I'm going to use also checkboxes to mean that I am saving or I'm done or I'm okay, right? I'm completing something, right? So I'm going to look for that as well, consistency, right? Notice that the iconography is centered on the header, right? That it has nice padding on above and below and from either side. I'm going to look for that as well. Okay. The bottom side is nicely centered, all right, and has some padding. So a good use of white spaces. Okay. So I'm going to add plus here. This navigates me to a different HTML that we didn't have before. So notice that there was an AJAX call to go fetch that HTML, to go fetch that portion, right, that renders this particular page, right? And we can see the HTML over here. That's the HTML. This is the raw HTML. Notice that it's a snippet, right? It's not a full-blown HTML page, right? It's only a snippet. Right? It's meant to be embedded in a larger application, right? Okay, no, JavaScript was already loaded. Okay, no, never mind. So okay, this allows me to create a website. Again, notice the input fields are all consistent, right? Have all the same styling, right? They're all taking up the entire width of the phone, right? And also the text area is also taking up the entire. This is not the default behavior of the input field. I see the default behavior. I want it all to be styled consistently, right? So a new website. So let's see. I'm creating a new website that allows me to, I don't know, create education portal. Or how about CS5610, a new website. So this is a website that I'm creating. I can have many websites, right? This is just one of them. Maybe I can create a website for another website for CS4550. Okay, and notice that the consistency here, right? Notice that I now have a checkbox on the top right, that's kind of like an okay, I'm done, right? And once I click on that, it's dismissed, right? And it goes back to where I was. Or I can cancel by clicking on this back button, meaning I don't want to create a website. So you should have also these kind of navigations, right? Where you have very clearly marked exits from this. And notice also this is kind of like a dialogue, right? If you were on a desktop, a better experience would be to perhaps bring up a dialogue. Yes? But on a small screen, dialogues are less useful, right? Because you have a smaller real estate. The entire screen, right? Whether we wanted to, maybe animate it from the bottom or animate it from the left or something like that, that looks like a dialogue, that's okay, right? But you should take up as much space as you can because of the small screen. All right, so also notice that I have some decorators on the right-hand side that presumably mean the cog somehow means that I can edit or I can change the settings for that particular element. So I can go back, I can click on that and go back to what I had created earlier. So this is presumably a way that I can edit some content. This one allows me to delete the entity, the instance, or I can update it and provide some description. Right? You can say, again, there's an OK or a cancel. And down below, I have a couple other things I can share. I can share this website with someone. This one allows me to go back to my profile page from anywhere in the website, so I can log out or do meta information, meta things. Anyway, presumably this triangle might mean that I can execute or run or preview my website. Okay. One thing here is that those two icons are way too close to one another. Okay, especially on a screen, right? I could easily click one and not the other. Right, so I would add more spacing between them. Perhaps even make the icons a little bigger to make them easier to click on. Notice that I'm using blue, meaning that they're meant to be clicked on or interacted with. So again, use of coloring. So if probably the name is also clickable. From that, I navigate to pages. Notice that there's a kind of like a navigation from a top-down, right? Like a top-down hierarchical, right? From a user has many websites. Each website might have many pages. Each page might have many widgets, right? And there's kind of like a hierarchical relationship, and the navigation seems to be from left to right, right? That's also a very common way of organizing and laying out the navigation of your pages, right? Also, it points out kind of like the relationships that we might have in common relationships that we might have in a website. In any application, is that we have a one-to-many relationship here, several one-to-many relationships. We have that from the user, we have a one-to-many relationship with websites, right? So we have one user has many websites, right? And that each website has many pages, right? One to many, right? And that each page might have many widgets, right? Okay, and this UML diagram, we can identify and recognize a hierarchical relationship between all these, right? So we need to come up with a data model, right? And my expectation is that you would do something similar for your project, right? You would identify the data model and how the relationships is between all these, right? We need to come up with a mechanism by which we can access all, and navigate this data model to retrieve all these pieces of information, right? So for instance, I guess I should record this. Stop screen sharing. Okay. Oh, this is terrible. Wait. Right, so I was pointing out here that we have these entities, right? We have several one-to-many relationships of a user related to many websites, websites related to many pages, pages related to many widgets, right? And we need to come up with mechanisms by which we can navigate this data model, right? We need to design URLs that can map, right, requests from the outside world, right, from our client, right, asking for data, asking, hey, I have this user, give me the websites for this user. Okay, I have this website, give me the pages for this website. Hey, I have this page, now give me all the widgets for this particular page, right? So we're going to be using RESTful URLs that are going to allow us to retrieve all this data. For instance, if we want to retrieve a user, we might use something like this, API, right? We're gonna use the convention that if we're asking for data from the server, we're gonna prepend it with an API, right? So that we're asking either for static content or for dynamic data, right? So we're gonna follow this convention that if it starts with an API, the intention is that we're asking for dynamic data, not content or images or HTML or CSS or JavaScript. Make sense? Right? So we would start here. This would be the root, right? And we would start with with the top level of our data model, right? And presumably, we first have to identify which user. That's why usually the first thing you do is log in, right? So that we have a context. Right? The starting point is the user, and from there we try to navigate everything else that is related to that user. All right. So the API, the URL that we're going to use to retrieve data or create data or delete data or update data should reflect this relationships between the various entities, right? So we might start with user, right? That might be our first API call. That one, if you don't tell me which particular user, typically this is interpreted as I want all the users, right? Since you didn't tell me which one, right? This typically means I want all the users, right? And this will respond typically with an array of JSON objects, right? You'll have several JSON objects, one object per user. Now, should this be available to everybody? Probably not. Maybe to the admin user, perhaps. Yes, maybe an admin user should be able to retrieve the list of all the users and and remove a user or create new user or things like that, right? So this is typically an API that we might want to protect, right? It says that only if you're in a particular role you should be able to access this API, right? But nevertheless, that is the URL. Everybody okay? We could be a little more specific and say that we want a particular user, and we provide an ID of a particular user, right? So that URL should return just one object, right, for just one particular user. That includes username, first name, last name, and whatnot. Okay. If we continue, we'd say, following the hierarchy here of users, websites, and whatnot, we can use slashes and path, right, to mimic or to represent or map the hierarchical nature of our data model, right? So we can continue and say, okay, I want now the websites, website, okay? Again, since I'm not asking for any one website, this again, typically this is interpreted as you want all the websites. So this again would come back with an array of websites, okay, which we would be using it to maybe display in a tabular format, one row per website. Yes, right? If I provide an ID for a particular website, I get just one object, right? That represents that one website. Perhaps this one, where I don't provide a URL, a particular ID, this one would provide maybe a summary of the websites, right? Not everything, not all the objects for all websites, maybe a summary, maybe the names of the websites, right? Because I would just want to list them. Yes, I just want to list them in a table, perhaps, or a list, right? I don't want to have everything, all the information about the website, just maybe just the name and the ID, perhaps, right? But if I ask for a specific website, maybe that query is going to return the entire website, right? A lot of information, maybe the date when it was created, who created it, all sorts of statistics about that one website. Yes. Okay. Also notice that I'm using singular for all. You see that? That's up to you. I prefer for them to be singular, even if it's user, right, and you're returning an array, right? And the natural thing to do would be for this to be a plural, right? Because it's an array of things. Yes. Same thing for website, right? If I'm asking for many websites, typically I would be tempted to pluralize this, but I don't like to use plurals, especially because some words cannot be pluralized, right? Or they're not consistent. And I don't want to be thinking whether it's with S or ES or it has no plural. So I just stick with singulars, okay? It happened to me the other day. I was creating a website and it was fish. It says, oh man, I can't use plural, right? So there's no way for me to distinguish. So it says, see, it bit me. So no, I don't want to think about it. So just stick with singulars. Anyway, so websites, I can continue and say /pages or page, right? That returns all the pages for that particular website. Or if I say 345, it returns just that one page, right? And then I can ask for the widgets of that page, right? All the widgets, or a particular widget, right? And display a particular widget. Make sense, right? And along with this comes the actions that we want to do, right? Whether we want to create, update, or delete. Basically, the four CRUD operations that we can apply to any entity, right? Entities are all of these, right? User is an entity, a website is an entity, a page is an entity, a widget is an entity, right? These are all different entities in our data model, and for each one, we can provide CRUD operations, right? Create, read, update, and delete, right? If I want to read all the users, I would say get, right? And then API user, that returns all the users. If I want to read just one user, I also would use get, right? And it says get and then 1, 2, 3. Or retrieve just that one user, right? If I want to create a brand new user, I would say a post, right? API /user, right? I don't have an ID because the user doesn't exist, right? So I'm creating a brand new user. I'm posting to this URL, and alongside with this URL, typically I would provide some object, right? With username, password, and information to create that user, right? If I want to update a user, an existing user, typically I would use a put, a put. So it would be API user. If I'm updating, it means that I'm updating an existing user. So typically the URL would be put the API user / the ID of the user that I'm updating, right? And then the new values, right, for the objects for the either new first name, new last name, email, or phones, or address, or whatever, right? And finally, if I want to remove right, I would use an HTTP delete. Again, I would say API user. That's kind of dangerous. Delete all users, right? Typically, we would disallow that, right? We wouldn't allow that. But typically, we would only just accept the capability of just providing the ID of a particular user, right? That would just remove that one user from the database. Make sense? All right. So we'll come back to this, right? Because this is a very useful with the data that is stored in the database. You can notice that you can do the same thing with websites, right? You can say get returns all the websites. Yes. Get website with an ID that returns just one website. This website, which websites? The websites of that particular user, not all the websites, right? Only the websites that belong to this one user, right? I can post a website for a particular user, right? And so this is a post. This creates a brand new website for this user. Put updates a particular website for that user, right? For this particular user. And delete removes this website from that particular user. See that? All right. All right. I'm gonna leave it here, and we'll continue on Thursday. Any questions so far?
How do you validate if the API call is like not a malicious one in the sense that independently?
Yeah, the server needs to handle that, right? Typically, that user will be logged in, right? We'll be looking for cookies that say that particular is logged in or not, right? Verify that that particular cookie is from a token that we've provided, right? And we'll verify that the user exists, that it's in the correct role, right? We'll authenticate them, not only authenticate, but also authorize them, right? Yeah. Usually, security is two things, right? First, knowing that who you are, and then what are you allowed to do once you know who you are. So yeah, so certain APIs would be certainly protected, right? Yeah, so you will only a particular role. All right. So please get started on the environment, setting up your environment. Okay. Hopefully you have Node.js, at least the local side of it. You should be done within the day or so, right? And then work your way towards having the remote server running also by the end of the week. All right. All right. Thank you.